Imagine a world where your car drives itself, traffic light communicates with vehicles, and the road automatically adjusts to traffic conditions. This is not science fiction. It is future being built through two powerful technologies, the Internet of Things and driverless cars. In this video, we'll explore how these technologies work, how they support each other, and what impact they have on the society. We'll also examine the benefits, risks, future possibilities of the connected transportation system. What is Internet of Things? The Internet of Things, or IoT, refers to a network of physical devices that are connected to the Internet. These devices include sensors, smart appliances, wearable technology, and connected vehicles. Each device collects data from its environment and sends it to the other system through the Internet. This allows devices to communicate with each other and make automated decisions. For example, a small thermostat can detect room temperature and automatically adjust heating or cooling. In transportation, IoT allows vehicle, traffic light, and road infrastructure to exchange information in real time. What are driverless cars? Driverless cars, also known as autonomous vehicles, are cars that can navigate and operate without human control. These vehicles use combination of technology including camera, radar, sensor, AI, and advanced software. Together, these systems allow the car to detect obstacles, recognize traffic signals, and make driving decisions. Major companies such as Tesla, Waymo, and Uber are investing heavily in autonomous driving technology, aiming to create safer and more efficient transportation system. How IoT and driverless cars work together. Driverless cars depend heavily on IoT infrastructure and functional efficiency. For example, vehicle can communicate with traffic light to determine when they will change. They can also receive data from road sensors that monitor traffic congestions, weather conditions, or accidents. This type of communication is often referred to vehicle communication and vehicle to infrastructure communication. By connecting vehicle to the surrounding environment, IoT helps autonomous cars make smarter and safer decisions while driving. How the technology works. An IoT system usually follows four main steps. First, sensor collection information from the environment. Second, data is transmitted through connectivity technologies such as Wi-Fi or 5G networks. Third, cloud computing system process and analyze the information. Finally, automated system or users can act based on the information. Driverless vehicles follow a similar process. Sensors such as LiDAR, radar, and cameras scan the surroundings. Artificial intelligence systems then analyze the data to detect objects like pedestrians, other vehicles, or traffic signs. After analyzing the environment, the vehicle decides the safest path and controls the steering, braking, and acceleration. History and development. The concept of connected device has been developing for decades. In terms of Internet of Things was first introduced in 1999 by Kevin Ashton. Since then, the technology has grown rapidly, especially with the rise of smartphones, cloud computing, and high-speed internet. Driverless cars also have long history. Early research began in 1980s through robotics programming and university experiments. A major milestone occurred in 2004 when DARPA Grand Challenge encouraged the team to develop autonomous vehicles capable of navigating desert terrain. Since then, companies and researchers have continued improving the technology, and today autonomous taxis are being tested in several cities. Why use the technologies? One of the biggest reasons for developing autonomous vehicles is safety. Studies show that around 90% of the road accidents are caused by human error, such as distraction, fatigue, or impaired driving. Autonomous vehicles can react faster than humans, consistently monitor their surroundings, which could significantly reduce accidents. Another benefit is improved traffic efficiency. Connected vehicles can communicate with traffic management systems to find faster routes and avoid congestion. Environmental benefits are also possible. More efficient driving patterns can reduce fuel consumption and lower greenhouse gas emissions. In addition, autonomous vehicles could provide great accessibility for elderly individuals or people with disabilities who may not be able to drive. Human needs and desires. Beyond solving problems, the technology also meets their important human desires. People want convenience, comfort, and efficiency in their daily lives. Autonomous vehicle could also allow passengers to relax, work, or entertain themselves while traveling. Connected transportation systems also support the concept of smart cities, where technologies improve everyday living throughout the automation and data-driven decision making. Social and economic impact. The integration of IoT and autonomous vehicles could significantly transform cities and economies. In smart cities, traffic lights, parking system, and public transportation networks could be connected to optimize traffic flow. In cities such as Dubai, we are already investing in smart mobility initiatives to prepare for autonomous transportation. Economically, these technologies could create new industries related to artificial intelligence, data analytics, and smart infrastructure. However, they could also disrupt traditional industries, particular jobs involving driving. Risk and challenges. Despite their potential benefits, these technologies also raise important concerns. Cybersecurity is one of the major risks because autonomous vehicles are connected to networks. They could potentially be vulnerable to hacking if proper security measures are not implemented. Privacy is another issue. IoT systems collect large amount of data, including location and movement information. These raise questions about how the data is stored and who has access to it. Ethical challenges also exist. In rare situations where an accident cannot be avoided, an autonomous system may need to make difficult decisions that involve moral consideration. Finally, building the infrastructure requires a connected transportation such as smart roads and sensors can be extremely expensive. Obstacles to adoption. There are several barriers that could slow the adoption of autonomous vehicles. Public trust remains a majority challenge. People are still hesitant to trust machines with something as important as driving. There are also legal and regulatory issues to address, including determining who is responsible if an autonomous vehicle causes an accident. Technology's challenges also remain, especially in difficult weather conditions where sensors may struggle to detect surroundings. Potential problems. The widespread adoption of autonomous vehicles may also create unintended consequences. For example, millions of people worldwide work in driving related professions such as taxi drivers, truck drivers, and delivery drivers. Automation could significantly impact these jobs. There's also risk of over dependence on technology. If system fails and network go offline, transportation system could be disrupted. Additionally, there's concern that smart mobility technologies may initially benefit wealthier cities while leaving the others behind. Future outlook. Looking ahead, many experts believe that autonomous transportation will be playing a key role in future smart cities. Possible development include autonomous delivery vehicle, AI-controlled traffic management systems, and fully connected urban infrastructure. As technology advances, government and companies will need to work together to ensure that these systems are safe, ethical, and accessible for anyone. In conclusion, the combination of Internet of Things and driverless vehicle represent a major transformation in transportation. By connecting vehicle infrastructure and data systems, these technologies have potential to make cities safer, more efficient, and more suitable. However, it's also importantly carefully to address the risks related to cybersecurity, privacy, ethics, and employment. Ultimately, the success of smart mobility will depend not only on technologies innovating but also on responsible governance and public trust. Thank you for watching.